Well, hello, welcome. Um, Thank you for joining us today on our presentation of Humboldt Bay um, Sea Level Rise with Aldaron Laird. I'm Tamara Myers with Freshwater Community Guild, and thank you for joining us today. Hi, Aldaron.
I I
Hi.
forgot to turn that off.
It's okay. So, do you want to tell us a little bit about yourself?
Okay, are you ready to start? Yeah.
Yes.
And okay, my name's Aldaron Laird. I'm an environmental planner, and I mostly focus on restoration and enhancement projects in aquatic environments like estuaries and bays and California rivers. And since 2010, I shifted my focus over to looking into sea level rise and doing vulnerability assessments for sea level rise, specifically on Humboldt Bay. Just prior to in 2007, I completed or produced a historical digital atlas to show how the bay had changed from 1851 to present day. And back in 2010, the state asked a bunch of us if we had any ideas on what to do about sea level rise on Humboldt Bay. And I suggested, well, it hasn't been mapped. The shoreline hasn't been really mapped since 1870. We ought to start with that and map the shoreline. So that was kind of my beginning in sea level rise. And I've completed about 12 or more different sea level rise vulnerability and adaptation planning projects on Humboldt Bay. So that's kind of what has led me to where I am today. So
Wonderful. Just a housekeeping. If you have questions throughout presentation, if you could enter them into the chat, I'll monitor the chat and go ahead and we'll ask those questions.
it looks like you got a couple of more people coming in.
Huh?
And so should I just go ahead and get started?
Yeah,
Okay.
we're ready.
Okay. And so everybody, this image that you're looking at is the Wiyot's Tuluwa World Renewal Ceremonial site. And this is during a king tide, almost about 9 feet in elevation. And this is a ceremonial site, village site that the Wiyot have been occupying for hundreds and hundreds and hundreds of years. It's a shell midden that they built up above the tide elevation. And as you can see, it's still above king tide. So the Wiyot call Humboldt Bay Wiggy is their name for Humboldt Bay. And what I'm going to do today is explain sea level rise on Humboldt Bay, and then wherever possible, I'll try to show you how sea level rise might manifest on Eureka Slough in the Eureka Slough hydrographic area, because I know that's the area of interest for you folks. So historically, if we look at Humboldt Bay, about 60% of the bay was open water and mudflat, and about 40% of the bay was salt marsh. And the salt marsh occupied a little more than 10,000 acres at that time. And today, we still have about the same acreage of open water and mudflat, a little bit more, but we only have 10% of salt marsh. And so it's really reduced from 10,000 plus acres down to just 1,500 acres. So 75% of the shoreline of Humboldt Bay is artificial, and only 25% of it has a natural shoreline any longer. And if we look 100 years out from today to 2120, and we look at where king tide is going to go, king tides will rise to the 20-foot contour. We're expecting 3 meters or just about 10 feet of sea level rise over the next 100 years. So the blue bay shoreline will expand out to the yellow line that you see all around the bay. And there'll be some significant changes. The bay will go way up, Freshwater Valley. It'll go up quite a ways on Elk River Valley, and on Mad River Bottom and Mad River Slough. The Mad River will be flowing into Humboldt Bay by then. It won't be flowing out to the ocean. So we have some dramatic changes that we're going to face on Humboldt Bay just in the next 100 years. And so from 100 years ago to 100 years in the future, the bay is really a dynamic landscape. So looking at Humboldt Bay, it's part of the Eureka littoral cell. The sediment coming out of the Eel River moves offshore and it circulates up north towards Trinidad and creates coastal dune barriers that isolate the low-lying areas on the inland that become lagoons in other areas like a Big Lagoon, Stone Lagoon, and on Humboldt Bay, it's really very similar geomorphically to those lagoons. And there are no major rivers flowing into Humboldt Bay. It's just low-lying alluvial deposits. And that's what forms Humboldt Bay and how it's featured. And if we do a transect through Humboldt Bay, say over by the Mad River slough area on the north end of the bay, we start with the open ocean environment, and we have a barrier dune system, which is starting the spits that form the bay. We have high parabolic dunes that merge into coastal pine and spruce forests that go down to tidewater. And then we have intertidal wetlands and salt marsh and open water channels. And then ultimately it goes into the large open water environments of the bays on Humboldt Bay. And at low tide, we have extensive mud flats. And so Humboldt Bay really has quite a tidal range. When you go from mean lower low water to mean higher high water, it's about 7 feet in elevation on a daily basis. We have 2 high tides every day and 2 low tides. If you look at the tide elevation extreme for the year, looking at a king tide from mean lower low water to a king tide, which is almost 9 feet, we can have much more than a 7-foot spread. We can have closer to a 9 to a 10-foot spread. And above 8.8 feet, we have upland environment. So during king tides, we have really high water events that can go right up to the base of our bridges. And at minus tide, we have extensive mud flats and some submerged channels that traverse those mud flats. So it's really quite a range. We have some extensive storm surges and wind waves that can raise water elevation on the shorelines during those wind wave events. And when we look at the maximum water elevation that's measured at the North Spit tide gauge every year on an annual basis, you can see that there's a clear trend line of the tides, the highest tide of every year going up over time. So we've been experiencing sea level rise on Humboldt Bay. And when we look at king tides, freshwater areas can flood during king tide events. King tides impact king salmon as one of the communities at risk on the bay, as well as Fields Landing. Regular king tide flooding occurs. And this is the Fay Slough wildlife area. During king tides, you can have emerging groundwater that floods the dike former tidelands. And so it's another form of sea level rise flooding. And so if we look at Humboldt Bay, we break it up into hydrographic areas with a common shoreline and tidal features. There's really 6 hydrographic areas. There's the Mad River Slough, Arcata Bay, Eureka Slough, the Eureka Bay, and then Elk River Slough, and then South Bay. And so we have 3 bays, Arcata, Eureka, and South Bay, and we have 3 slough tributaries to the bays, Mad River, Eureka, and Elk River. Freshwater Creek flows into Eureka Slough. And so if we focus on the Eureka Slough hydrographic area, we have freshwater freshwater creek coming down. We have Ryan Creek that joins Freshwater Creek. And then we have Cochrane Creek that flows into Fay Slough. And Fay Slough joins Freshwater Slough. And from that point on to the bay, it's called or referred to as Eureka Slough. And so this is the area. It's mostly diked former tideland that's in agricultural land uses. There are an urban and commercial area over the Jacobs Avenue and the Murray Airport. And then on first, second, and third slough, there's residential and commercial areas around that. But most of the area is open agricultural land. And if you look at the individual hydrographic subunits, there's 12 hydrographic subunits on Eureka Slough. And, um, and these all shore, excuse me, these all share a common shoreline that's usually represented by a dike in all of the area below, behind the dike. If the dike were to breach in any location along its perimeter, all of this land would be tidally inundated. Here's another hydrographic unit or subunit. And then we have a couple more over here on the other side of freshwater slough. And so when managing or assessing sea level rise impacts, we look at individual hydrographic areas, and then we look at the subunits within those areas that are protected by dike shorelines. And so if you look at the Eureka Slough bottomland, and look at what it was like historically, this is the salt marsh and intertidal channels traversing the salt marsh as it was mapped in 1870 on freshwater slough. And so you can see it was really, on an extensive salt marsh wetland with many uh, tidal slough channels traversing all over, and some of them, many of them going directly to the bay, but off of Fay Slough. But ultimately, Eureka Slough was the dominant tidal channel that was feeding this area. And over time, we took this really diverse, complex landform, and we slowly simplified it until today. The tidal channels are all that are remaining of that historical landscape. And we have dikes along the very edge of all of the tidal channels, and all the salt marsh areas in the tidal channels in those salt marsh areas are now behind dikes. And that area is predominantly used for agricultural purposes. And so it was a major landscape conversion that began around 1890 on Humboldt Bay. And by around 1920 or so, 1930, it was pretty much complete. The Fay Slough freshwater area were some of the initial areas that were diked in the 1890s. And so they've been in agricultural production for a very long time, and they haven't been tidal for a very long time. So why do we have sea level rising? And it really all comes down to what we've been doing with our greenhouse gas emissions over the last century, a century and a half, 2 centuries. And as we pumped carbon dioxide and other gases into the atmosphere, we've warmed the atmosphere globally. And as the atmosphere warmed, the ocean has absorbed the majority of all that heat that's been generating through the greenhouse gas effect or greenhouse effect, heating up the atmosphere. As the ocean has warmed, it's expanded, and it's resulted in about 8 inches of sea level rise globally. But more importantly is it's warmed in temperature, and as it's warmed in temperature and the air is warmed in temperature, land-based ice areas like Greenland and Antarctica are now starting to melt. As the global temperature has gone up about 1 degree Celsius since the beginning of the industrial age. That's enough that the planet is warming, and as the planet warms, the ice is melting. As ice melts, the ocean increases. There's a relationship between land-based ice and ocean elevations. As the planet gets colder and we go into a glacial period, we get lots of snow that converts to ice, and the ocean levels drop. They can go a couple 100 feet lower than what we've experienced them now. And then as global temperature warms up and the ice starts to melt, as the ice melts, the ocean levels start to rise. And that's the phase that we're in right now. So until we get global climate cooling to start occurring, we're going to continue to have sea levels rise as a result. As the ice continues to melt, it could take centuries for all the ice to melt. And so as a result, the sea levels will continue to rise for centuries until we go into a period of global cooling. And so it's not something that we will get over in any short time. We're just now dealing with it, just starting to learn and study about it on Humboldt Bay since 2010. So we're really at the beginning of a major landscape change that we and all the generations that come after us are going to have to deal with on Humboldt Bay. And so when we look at sea level rise, what you really, there's global or eustatic sea level rise. There's regional sea level rise, like the north East Pacific, which is the shoreline of North America from Alaska on down to Baja. All of that area has its own characteristics. And so the sea level rising off of the coasts of San Francisco or Arcata or Southern Oregon is all the same. And it's gone up about 8 inches through thermal expansion. But when you look at the sea level rise at a specific location like Humboldt Bay, we have a tide gauge on Humboldt Bay. You have to take into account what the ground is doing. In a lot of areas on the planet, the ground is stable, it's not moving. Where we are located on the West Coast with the Triple Junction just off of Cape Mendocino, we have a pretty extensive tectonic activity. And so a local group, Cascadia Geosciences, looked at what was the vertical land change trends in our region of the coast. And what they found was is that our area, the Humboldt Bay region, is actually subsiding. So as the ground goes down, even if the water level wasn't changing, sea level would be rising on Humboldt Bay just because the ground's going down. So Northern Hydrology and Engineering took into account the vertical land motion trends and the regional sea level rise trends and came up with sea level rise projections for the Humboldt Bay region. And as it turns out, if you look at all the tide gauges that are monitored on the West Coast by NOAA, you'll notice that all of them are on green and they're all elevating based on the regional sea level rise. But there's a couple of areas, one in particular that's yellow, and that's the North Spit tide gauge. We have the highest rate of relative sea level rise in the entire West Coast of North America. And coincidentally, right next to us, the next tide gauge up the coast is at Crescent City, and it has the lowest rate of sea level rise. So the two extremes for sea level rise are side by side, and that's because our tectonic activity, while we're subsiding down at the lower end of the Cascadia subduction zone and with the Gorda plate off the coast of Cape Mendocino at Crescent City, the Pacific plate is going underneath the North American plate and it's buckling up the surface. And so the ground is actually uplifting in Crescent City at about the same rate as what sea level rise has been doing. And so there's been no net change in sea level rise in Crescent City. Of course, that begs the question, well, what will happen if we have another Cascadia event like we had in 1700? And we really don't know. We could either have 3 feet of instant sea level rise, or we could go up. It's really not known at this point. And if we look at the sea level rise projections starting in 2010, when they first started coming out from the state, essentially we were told to plan for a half a foot by 2030 and 1 foot and 3.9 feet by the end of the century, or 4 feet. And they came out with, a state came out with new projections in 2013. And then most recently, they came out on projections in 2018. And now in 2030, we're told to expect 1 foot of sea level rise. And by 2050, what went from 1.2 feet of projection, we're now told to look for 2.3 feet. And by 2100, instead of it being around 4 feet, we're told to expect 7.5 feet. So every time the state and national or global organizations do sea level rise projections, what we are seeing is they revise upwards and upwards and upwards. Particularly after 2050, the rate of sea level rise seems to accelerate quite a bit. So I imagine the next time they do a new sea level rise projection in 5 years, I would not be surprised if the rates above for 2050 and beyond are higher than what we're working with now. But the state of California in 2018 issued sea level rise projections for the North Spit tide gauge. So we know what is projected on the North Spit. And they came up with a low risk aversion and a medium and high risk aversion projection. And then they included a new thing called the extreme risk aversion. And for the first time, the state of California took into account what would the melting of Greenland contribute to sea level rise. the International Governmental Panel on Climate Change doesn't factor in land-based melting contributing to sea level rise from Antarctica or Greenland, because they don't have enough certainty or confidence in being able to predict how much is coming from it. They know that there's a lot of water coming from those areas. They just don't feel confident in saying anything, so they haven't said anything. So their projections have been very, very conservative. And so for the first time, California is brought that in. And just for example, for 2100, the high projection for 2100 is about 7.6 feet by the end of the century. The extreme projection based on contribution from Greenland would put it at 11 feet. And so it's a changing and continually modifying science that we're working with. And when you look at sea level rise, you really need to look at what tidal datum. We have mean high water that occurs twice a day and occurs almost every day or every other day. We have a mean high water. We have monthly high water events, and we have king tide events that occur a couple of days every year. Flooding from king tides is considered a nuisance flooding. Flooding from a monthly high tide is considered chronic flooding, because you don't know what day of the month you're going to achieve that monthly high tide. And then flooding from daily high tides is really submersion, or you're part of a tidal water at that point. So with changes in sea level rise, we can expect some, how will the landscape respond? So if we look at the Eureka Slough area, the image on the left shows you what would happen if the dikes on Eureka Slough were to fail. And the blue represents open water, the green represents eelgrass, the dark brown is mudflat, and the gold color is salt marsh. So if the dikes failed, they wouldn't convert to salt marsh because the ground has subsided over the last 100+ years. A good portion of the Eureka Slough area would actually convert to mudflats. With 1/2 meter of sea level rise, which is about 1.6 feet, something that we would experience before 2050. Um, you can see with just a little bit of sea level rise, most of the Eureka Slough hydrographic area would convert to mudflats, and there would only be a little bit of salt marsh going up the freshwater valley, and almost entirely the Eureka Slough hydrographic area would be mudflat. With 1 meter or a little more than 3 feet of sea level rise, which is projected to occur by 2060, again, we just have a little bit of salt marsh at the upper end in Freshwater Valley. The water is getting deeper, so we're getting expansion of eelgrass into Eureka Slough area and still have extensive mudflat. And with 1.5 meter or 5 meters or 5 feet of sea level rise, something that could occur maybe around 2070, 2080, the water again is deeper. As you notice that the sea level rise inundation area is not really expanding. The water's just getting deeper because all around the Eureka Slough hydrographic area is foothills. The only area for the sea level rise to expand is up Freshwater Valley. I mean, it's running into elevated areas all around, but that's how the present day landscape would respond to sea level rise going forward. We would see changes in habitat, intertidal habitats in place as water elevations get deeper and deeper. And just recently, or 15 years ago, on the New Year's Eve storm in 2005, ended up, the governor declared a state of disaster on Humboldt Bay. The bay essentially filled up right to the top of all the dikes and started spilling over the dikes all around the bay. And that was the highest water elevation recorded at the North Spit tide gauge. And it was 9.6 feet is what it was a king tide, and it was a storm surge or wind waves that elevated the water above just the king tide elevation. An average king tide is 8.8 feet. So that state of disaster ended up occurring with less than 1 foot of sea level rise during that storm. So you can see the precarious nature that we are at in Humboldt Bay when only less than 1 foot of sea level rise results in a state of disaster being declared. And so if you look at that state of disaster water elevation, by 2030, with 1 foot of sea level rise, the average king tide could exceed that state of disaster. So we could have a state of disaster declared every winter on Humboldt Bay with 1 foot of sea level rise. With 2 feet of sea level rise, the monthly high tide would exceed that state of disaster water elevation that we just experienced. And by 2060, with 3 feet of sea level rise, the daily high tide would equal that state of disaster water elevation on Humboldt Bay. So you can really see we're going to start experiencing some major water elevation induced changes on Humboldt Bay in very short order. It's not out at 2100 when the changes are going to start happening. The changes are really going to start happening before mid-century. By probably 2040, we'll start seeing quite a few major changes in Humboldt Bay. And so one of the first things that we did to try to figure out how the bay is going to respond to sea level rise is we did a shoreline mapping and inventory, and we did a vulnerability assessment of the shoreline back in 2013. And what we found was is that 75% of the shoreline is made up of an artificial structure, and only 25% of the shoreline is a natural shoreline. So of the 102 miles of shoreline that we have now, 77 miles are artificial, which means those shorelines structures need to be maintained if they're going to continue to hold back the tide water from the former salt marsh around the bay. And when we mapped it, we identified what type of shoreline structures were out there. And like on the Eureka Slough, the areas in yellow are dikes. The area in red is the railroad. Green is natural shorelines. And we have some fill or bulk work areas. And so we've mapped what type of shoreline structures out there to see, the vulnerability of that structure. We then looked at around on the shoreline, and we identified what areas were actually eroding and exposed, what areas had been fortified with rock or concrete, and about 9 miles of the shoreline is actively eroding. And again, when we zoom in on the Eureka Slough area, we can see the areas in red that are actively eroding along the shore, and where there is rock armament on the shore, like on Jacobs Avenue and stuff. And so an exposed shoreline that's made out of a dike, once that shoreline is eroded all the way through the dike, then you'll have tidewater inundation of the former tidelands behind the dike. And we have a lot of vegetated shoreline on Eureka Slough. And the problem with this is that vegetation prevents the property owner from maintaining the shoreline. They can't drive out on the dike with a rock truck or a backhoe and do maintenance and upkeep of the shoreline. Most of the shorelines are totally covered, and there's, if anything, there's a cattle trail on top of the dike, and that's about it. So a lot of the shorelines have not, dike shorelines have not been maintained. They're not open for vehicles. And we created a shoreline profile on Humboldt Bay. We wanted to identify the elevation, today's elevation of the shoreline in relationship to the monthly high tide. We selected the monthly high tide as our tidal datum to measure sea level rise on Humboldt Bay. And we've identified segments. The areas in red are only 2 feet higher than the monthly high tide. And the monthly high tide is 7.7 feet, so a little bit less than 8 feet. So these areas in red are just under 10 feet in elevation. The areas in yellow are just under 11 feet in elevation. They're 3 feet higher than the monthly high tide. And that'll become evident in a little while why we mapped 2 feet above the monthly high tide and 3 feet above the monthly high tide. We wanted to figure out how vulnerable the shoreline was. So we looked at all the segments that are actively eroding and all the low elevation segments that are within 2 feet of the monthly high tide. And we found that about 59 miles of the shoreline, again, when we look at the Eureka Slough area, all the areas in red, we consider vulnerable shorelines because they're low in elevation. They would be overtopped with less than 2 feet of water elevation increase, or they're actively eroding, or both. And so these are the shoreline segments that should be addressed first if we want to protect the integrity of the dike shoreline so the lands inland don't get flooded. So, and this is what a diked shoreline that's actively eroding looks like. You can see all that's left is is a little trail along the top. You can't drive vehicle access, but these dikes that were created beginning back in 1890 really left us a historical legacy that we are just coming to bear to deal with right now. And so if we look at where the tides go on a daily basis, here's the Eureka Slough area. You can see Eureka Slough, Freshwater Slough branching off here, and Fay Slough going out this way. If that dike breaches, the agricultural dike are breached. This is not with sea level rise. This is the historical legacy that I mentioned. When they diked off the salt marsh and they prevented daily tidal inundation, the ground has stopped raising in elevation. There's no new sediments coming in. So the ground actually is compacting and is lower. But by that artificial shoreline, um, these lands behind the dike are extremely vulnerable. The bay would essentially reclaim all of its former salt marsh in a day if the dikes are breached. And so those dikes have to be maintained. They have to keep back the high tides on a daily basis, or this is the area that would become tidally inundated. As I said earlier, the bay would reclaim its salt marsh, and this has nothing to do with salt marsh, I mean with sea level rise. So when we did that shoreline mapping and vulnerability assessment, this was the most unforeseen finding that we came across, is we're extremely vulnerable and at risk right now, regardless of sea level rise. Sea level rise is just going to make it worse. And so when we look at the elevations, how many miles of shoreline are at what elevation, um, we found is that when there's about 11 miles of shoreline that's less than is 2 feet above the monthly high tide, and there's 23 miles of shoreline that are at 3 feet above the monthly high tide. So when we go from 2 to 3 feet of water elevation increase from sea level rise, that is what we call a tipping point on Humboldt Bay. Almost all of the diked hydrographic units on Humboldt Bay would become breached and overtopped if that was to occur. And that could occur between now and 2060. And this is what it looks like on Eureka Slough. With 2 feet of sea level rise, the areas in red could be overtopped by the monthly high tide. With 3 feet of sea level rise, the area on the right shows you all the shorelines that could be overtopped with 3 feet of sea level rise. So of the dike shoreline on Humboldt Bay, 27% could be overtopped by 2 feet, and more than 56% could be overtopped with 3 feet of sea level rise. And so that's a critical vulnerability that we have. And in the Eureka Slough area out there on California Department of Fish and Wildlife Refuge on Fay Slough, they, when we completed that shoreline vulnerability assessment for sea level rise, they did a focus study on the Fay Slough wildlife area, as well as the Mad River Slough and the Elk River Slough. And they identified, within the refuge boundaries, those shorelines that were really at risk and should be addressed. And this was done in 2013, and I'm not aware that anything has been done on the wildlife refuge to address those since then. But the other historical legacy that we have on Humboldt Bay is related to the entrance of Humboldt Bay. This is what the entrance of Humboldt Bay looked like in 1851. We had a channel that came in. We had South Spit and North Spit, and we had this big hill right across from the entrance. It was called Red Bluff or Booner's Point, and it was really a very tall hill, 150, 170 feet in elevation, I believe it was. And they were building a town there called Humboldt City, kind of where King Salmon is today. But anyways, when the jetties were constructed starting in the 1890s, when some of them were completed, what they did is they funneled all the wave energy coming through the entrance of the harbor between the two jetties, and all that wave energy ran right into the red bluff of Bunner's Point, that big hill that I was telling you about. And that was where the shoreline was in 1870. And from 1890 to 1950, when they rocked the shoreline retreated 1,480 feet in 60 years because of the wave energy being focused on that point. So this is the most erosive location on all of Humboldt Bay. And the shoreline had built up as seawalls. This is along the railroad, right next to King Salmon, and then right along Booner's Point. They also built a seawall, and now we have king tides overtopping that seawall. And here's that bluff that's all forested. Since they rocked it, it stopped eroding, and it's become covered in foresting. But PG&E went in when they dismantled the Humboldt Bay nuclear power plant. They took all the nuclear fuel and they put it in these silos. And these silos are located 115 feet back from the shoreline that's being protected by those rocks. But as you can see, the king tides now are starting to overtop that seawall. And when we looked at the earlier side, this location is the highest rate of sea level rise. We had almost 1,500 feet of sea level rise in 60 years. And there's only 115 feet between the open ocean and the nuclear fuel storage silos. It was not a very good place to locate something like that in perpetuity. There's nowhere to move these nuclear fuel rods to. They or will stay there until the federal government creates a depository. And so that's pretty much what we found about Humboldt Bay with the initial investigation into the shoreline, which is really our frontline defenses for sea level rise. And in planning for sea level rise, you usually do vulnerability assessments, and then you take the information from that and start doing adaptation planning. And vulnerability assessments really revolve around some basic questions: is how is sea level rise going to impact this area? When is sea level rise going to occur? Where is sea level rise going to go? I mean, what areas are going to be flooded, and what is in those areas that are going to be flooded and impacted by sea level rise? Who is going to do something about the sea level rise impacting those assets in those areas, and what can they do to stop and protect against sea level rise? So those are the sort of things you deal with in vulnerability assessment and in adaptation planning. And so the type of impacts that we could experience with sea level rise are tidal flooding, inundation, overtopping the dike shoreline and filling up the areas. This is over on Freshwater Slough. We have shoreline erosion of the dikes, and they breach and the tides come in and inundate an area. The other thing that sea level rise does in flat alluvial deposits like what we have around Humboldt Bay is groundwater, which is freshwater, is less dense than saltwater. And so the saltwater permeates underneath the ground on the inside of the dikes. It goes underneath the dikes and underneath the ground. And so during high tides, extreme high tides like king tides, we can have the groundwater emerging. And so with sea level rise, the groundwater could emerge. And so we could actually have flooding as a result of emerging groundwater, even though the shoreline structures are still intact. And then you can also have stormwater flooding as a result of sea level rise and saltwater intrusion. And so in looking at Humboldt Bay and what is, has occurred with this, we've done a number of studies on Humboldt Bay. I've highlighted a few. We had an adaptation planning group, and we did 2 vulnerability assessments, and one was on all the dike lands of Humboldt Bay, and the other was the entire 101 highway from Table Bluff all the way to Arcata. And we did that back in 2015. The city of Eureka did a vulnerability assessment, and they included their planning area, which covered all of the Eureka Slough complex. That was done in 2016. And Humboldt County did a sea level rise vulnerability assessment in 2018, and that covered all of the unincorporated area of Eureka Slough, which is the majority of Eureka Slough. And then the county also did a dike shoreline sea level rise adaptation feasibility study, because almost the entire shoreline of Eureka Slough is diked structures. And Caltrans did a focused a corridor study between Eureka and Arcata, which covers the Eureka Slough Bay frontage back in 2019. And just recently, Humboldt County completed a sea level rise adaptation plan and vulnerability assessment of the entire Eureka Slough hydrographic area, but they mostly were focusing on transportation infrastructure like the county roads and Murrayfield Airport and Highway 101. Um, Caltrans also did back in 2015 a climate change pilot study, and part of that was looking at sea level rise, and they did select the Arcata Bay to study sea level rise, which included the Eureka Slough area. So when we're looking at what could possibly be impacted by the areas that could be tidally inundated, we've identified different assets, and there's utility assets like wastewater collection systems and lift stations, municipal water transmission lines. There's two Eureka, or City of Eureka has, in Humboldt Community Services District, have water lines that travel from Arcata all the way down to Eureka over there by Ryan Slough, and they are buried across the Eureka Slough hydrographic area behind the dikes. We have transportation infrastructure. We have an airport in the Eureka Slough area, and we have a defunct railroad that's being converted to a trail. And of course, we have Highway 101 and local roads. We have land uses that would be impacted, primarily agriculture, but we do have commercial land uses in the Jacobs Avenue area and residential and public lands such as the Murrayfield Airport. There's coastal resources such as agricultural lands, wildlife refuges, WEOT cultural sites, coastal wetland areas. And then lastly, I wouldn't consider it an asset, but we have contaminated sites that are potentially going to be tidally inundated with sea level rise. So we've mapped all of those assets on Humboldt Bay, and not surprising, dike shorelines on the bay are the most vulnerable area that we found. And dikes are barriers, but they're not long-term solutions to sea level rise, unfortunately, because of drainage. We have a lot of stormwater runoff. We have major storms that hit the Fickle Hill, the Neelan Crest. All that water rushes down into the bay. It runs into the dikes, and it has to drain through tide gates in order to be able to drain into the sloughs, and then from the sloughs into the bay. And so with sea level rise, those tide gates are going to become less efficient. Most of the tide gates are oriented to the mean low water elevation. So with sea level rise, it's not just the high tides that go up, the low tides also go up. And so the tide gates will become less efficient on draining. So the areas behind the dikes will become backwater flooded. But also with sea level rise, and this is an instance of where we have stormwater runoff that runs into the high tides and it floods the farm fields. But as I mentioned earlier, with groundwater, as sea level moves in and raises the elevation, it pushes groundwater up until it emerges. And there've been some groundwater studies done on Humboldt Bay, and essentially the groundwater on dike former tidelands is less than 3 feet from the surface on average during the year. And in the winter, the groundwater is right at the surface, and with stormwater runoff, a lot of those ag fields don't drain for months at a time in the winter. And so with rising sea level rise, we'll see that the groundwater will essentially become emergent water and start occupying greater and greater areas, uh, uh, mostly starting with the dike former salt marsh and then expanding from there. During a recent king tide, the Fay Slough wildlife area, we had emerging groundwater flooding, and king tides were not overtopping the dikes on the wildlife refuge. This was purely sea level rise pushing up the elevation. Tamara? Oh, you're muted. Oh,
Sorry about that. We have a question from one of the participants. Jan asks, what will happen regarding the ability to access freshwater, like near, Wrangletown, near the Freshwater Community Hall in the next 20 years? Like, is our old Arcata Road going to be underwater?
Um, Sea level rise is going to push up to beyond Old Arcata Road and Three Corners, and it will move up the freshwater valley with probably by 2060 with 3 feet or more of sea level rise. Certainly with 2 meters of sea level rise, or that's about a little more than 6 by 2070. It will affect the lower reaches of freshwater valley, and it will have saltwater intrusion into any wells that might occur in that region. If you're on municipal water, if you're getting your water from the Humboldt Community Services District, those water lines would not be penetrated by saltwater intrusion.
Okay. I just want to let anybody know you can type your questions into the chat. You could turn your video on and give me a wave. So thank you.
Okay. And so we emerging groundwater is definitely to me is the most incipient impact from sea level rise, that on these dike farmer tidelands we really do not have the means to protect ourselves from. There's almost 8,000 acres of dike farmer tidelands that got removed from the bay, and if we wanted to raise the surface elevation 3 feet to stay above sea level rise through 2060, we would need 2,400 acre feet of fill, and we don't have that kind of fill to fill in that area to raise the elevations. So they definitely are vulnerable landscapes. And looking at where emerging groundwater is likely to occur, if we look at where it used to be salt marsh, this is a map that shows you the extent of the salt marsh in the 1870s. Here's Myrtle Avenue or Old Arcata Road. Salt marsh did go beyond that area. So anywhere that is in the boundary of the former salt marsh, the groundwater is less than 3 feet from the surface. And this is an area that would be affected first by emerging groundwater and saltwater intrusion. Farther up freshwater valley wasn't salt marsh, and so that is an area that would have to be inundated by new sea level elevations. And so I think it's less at risk up front, but in the latter half of the century it could become more at risk. And here's the wastewater collection lines in the lower Eureka Slough area. And we have individual lift stations which pump the sewage into a higher elevation pipe so it can all drain through gravity feed to the wastewater facility on Elk River. So lift stations are electrical devices. They don't like being inundated by salt water. And if you have old concrete sewer lines or sewer lines that have breaks and you get inflow into the sewer line, if you have saltwater intrusion and it gets into the wastewater collection line, it goes to the wastewater treatment plant and it can stop the wastewater treatment process when you have saltwater intruding into that. And of course, we have the Mad River pipelines that are buried across the Eureka Slough area. And so maintaining those areas with tide water, of 2 to 10 feet will be really difficult. We have communities on Humboldt Bay that are at risk. King Salmon and Fields Landing, this is just with 1/2 meter of sea level rise that we could easily have by 2040. And you can see much of King Salmon and Fields Landing would be experiencing monthly high tides flooding those areas. With 3 feet, which we could occur by 2060, the entire communities, even the waterfront of Fields Landing, is overtopped on a monthly basis. And so these communities just won't be habitable probably in another 40 years. So this is a significant impact on Humboldt Bay. The Humboldt Bay generating station, the new station that PG&E has installed, it's vulnerable to being inundated on by king tides and monthly high tides with 3 feet of sea level rise by 2060. The Eureka waterfront, the bulk cargo facilities, all of those are vulnerable. The Chevron bulk fuel terminal, those storage tanks are right there at the water's edge. Our marinas in Eureka and in Woodley Island. And when the last hazard area mitigation plan that was released in 2019, they looked at all of the property that would be affected by 3 feet of sea level rise and 8 feet of sea level rise. and they figured out how many parcels, how many buildings would be exposed, how many people would be exposed, and what's the value of the structures and the content. And they came up with 3 feet of sea level rise on Humboldt Bay could affect 620 people, almost 300 structures, and almost $400 million worth of development. With 8 feet of sea level rise, that jumps to 2,600 people affected, uh, 1,100 structures, and $2.3 billion worth of development that could be affected on Humboldt Bay. And so there's been almost 12 vulnerability assessment and reports that have been done on Humboldt Bay. And so the county wanted to compile all that information and organize it by hydrographic unit. So we compiled all of that information into a report that we just released in 2020. And this is available online for you if you want to. And we looked at the 6 hydrographic areas and the 24 hydrographic subunits, which are diked areas. And we organized all the GIS data that we collected. And so we can tell you how many acres would be inundated, how many miles of shoreline would be affected, what the shoreline is made of, what type of structure, what type of cover. And we've generated maps for each of the hydrographic areas. Like this is Eureka Slough. It shows you where the artificial shoreline, where the natural shoreline is, where the tide gates are. What type of shoreline structure is located, whether it's dike or natural or what other feature, what part of the shoreline is exposed. All of this is quantified in those tables. And then it goes on to identify what shorelines actually have salt marsh that possibly are protecting the shoreline, which shorelines are less than 10 feet or less than 11 feet, and the vulnerability rating. So all of that has been tabulated in those tables and generated in these maps. And so this is the area of Eureka Slough that has salt marsh or has no salt marsh. Here's the areas in red that are less than 10 feet. The areas in 11 are less than 11 feet in shoreline elevation. And here's the vulnerability ratings that for the Eureka Slough area. All the areas in red are highly vulnerable shoreline segments. So all of this data has been compiled, so you don't need to read the 12 vulnerability assessment reports unless you want to, but you can go to this one document, and the GIS data is available online. And we've looked at land use and jurisdictions. We broke it down as to how much of the area is in agricultural or residential or commercial, what portion of the area is in the city of Eureka, in the county's jurisdiction, or in the Coastal Commission's retained jurisdiction. And then we looked at those attributes like cultural sites, wildlife refuges, contaminated sites. And so all of this has been quantified for each of the areas, including Eureka Slough. Then we looked at how many miles of water line or sewer line or gas line, how many electrical transmission lines, and all of this has been mapped and then quantified for each of these hydrographic areas. And then we looked at transportation infrastructure and again quantified how many miles of different types of features and where they're located. And so with all of that information, it kind of comes down to what can we do to adapt to sea level rise? And that's really sort of the big question of that we're all facing is what can we do? And so we have some very concerned constituents out there that want to know what we're going to do. And so one of the first issues that we have to deal with is because so much of the shoreline, 41 miles or more on Humboldt Bay is dike shorelines, is who owns that dike shoreline and are they maintaining it? There's no dike reclamation district on Humboldt Bay that maintains the entire shoreline of Humboldt Bay. And so we have individual property owners, some of them protect their shorelines and others don't. And so it's going to be really hard to protect an entire hydrographic area if we can't get or solicit the cooperation of all the landowners. And some landowners, just aren't doing anything. And some of the dikes are right at the tipping point of a king tide, ready to breach and flood all the lands behind. And we could see multiple breaches on a yearly basis, probably in the next 10 years. And so one of the other things that's complicating in dealing with adaptation is that whose jurisdiction is controlling the shoreline. And what you can see here, the area in blue is all in the state's retained jurisdiction, the Coastal Commission. So the entire shoreline that would need to be maintained or raised or something done for sea level rise is actually in the Coastal Commission's jurisdiction, not in the county's jurisdiction or the city of Eureka's jurisdiction. So working with the Coastal Commission will be really an important step. And the Coastal Commission has issued sea level rise guidance on how to address sea level rise and even specifically for residential areas. And while dikes can protect low-lying areas, they can only do that until emerging groundwater floods the areas behind the dike. So rocking a dike and maintaining it, having good roadway on it is really good in the near term. But ultimately, with emerging groundwater, the utility of that will be expensive. And building a dike like this costs about $2.5 to $2.7 million a mile. So when dikes start to erode, this is a typical cross section of a dike. You can have rock slope protection on the bay side. You have enough width on the top for vehicles. You have 2-to-1 slopes and a drainage ditch. And as dikes erode away, you can rebuild the eroded part of the dike, but you're placing fill in the bay, and that's difficult to do with the Coastal Commission. So you can rebuild the dike on the backside and reestablish the width of the dike by filling on the backside. But because they're dike former tidelands, those are also wetlands, so that's difficult to do. Some of the other techniques are being explored are what are called living shorelines or salt marsh plain, to build a big salt marsh plain, which is a wetland habitat. So you would be able to do that on the bay side instead of trying to put rock on it, or abandoning an old dike and building a new dike into the interior and leaving the old dike to become a barrier island to break the wind waves and allowing the area that was former tidelands to be restored as salt marsh. So when we look at all the diked hydrographic areas and we quantify how many utilities or transportation or other assets are in each one of these 24 areas, we were able to come up with what could be considered high priority diked subunits based on the number of assets that are being protected. In the area between Eureka Slough and Fay Slough and Highway 101 is a real high priority uh, diked hydrographic subunit, and one that deserves a lot of attention just because of a number of utilities and other infrastructure. And so building dikes is obviously could be our first step on how to protect these areas. We could also try to use sheet piles or different types of bulk works that take up a smaller footprint. But there's also there's a lot of discussion coming on about living shorelines, and I helped put together a study on what type of living shorelines and where might they be used on Humboldt Bay. And there's areas where we can restore former salt marsh that eroded and create a barrier island front to them to, say, protect Highway 101 and the New Bay Trail, or to protect the Brainerd's area, or rebuild salt marsh that has eroded away. And along Jacobs Avenue, there used to be salt marsh. You could rebuild that there. You could also relocate dikes. We have a dike along Fay Slough. We could build a new dike that's shorter and straighter and convert the old dike into a barrier island to protect the new dike and let salt marsh occur in between and continue to use that area. We could do that on a number of dike locations. There are these living shoreline techniques that could be explored, as opposed to investing $2.5 million a mile for new shorelines that will only have limited value because of emerging groundwater. Ultimately, if we look out to 100 years from now, the shoreline of Humboldt Bay is going to go from where it is in blue along Fay Slough and Freshwater Slough, and the bay is going to go all the way up to where the yellow boundary is. And you can see it's going to push beyond Old Arcata Road, and it's going to go a ways up Freshwater Valley. There's not much we can do to stop the bay from expanding and from sea level rise increasing up to the 20-foot elevation with king tides by 2120. All of this area between where the shoreline is now and where the shoreline will be in 100 years, we have time, but not a lot of time, to figure out what to do to try to relocate these assets that are located there. But we can also try to protect the shoreline and prevent, the bay from expanding. Here's a sea wall across from the entrance of the bay, and even seawalls can be overtopped and waves can wash through. And it's done quite a number on the railroad with the recent king tides we've had. There's the idea of building houses up and allow for a breakaway floor so you can accommodate 10 feet of sea level rise. You can build out over water if you want to build out over water. Obviously, most of Eureka's slough is agricultural land, so unless we go to aquaculture, it would be difficult to maintain an agricultural venture. You can relocate some assets because they don't need to be on the shoreline. The original Humboldt Bay nuclear power plant was water cooled, so they had canals coming into the bay, into the power plant and out of the power plant, and they used the water from the bay to cool the nuclear power facility. Well, when they shut that down and they switched over to natural gas, the power plant doesn't need to be where the old nuclear power plant. They could have built it up on Humboldt Hill, completely away from sea level rise. So I would imagine between now and 2060 or thereabout, as water elevation comes up and the power plant starts getting flooded with king tides and then monthly high tides, PG&E may very well reconsider relocating the power plant somewhere else. But can you relocate a community like King Salmon and Fields Landing? I mean, where do you move? Fields Landing is a historic community going back to the 1880s. Was a railroad terminal and then a shipping port, for Pacific lumber. It had a whaling uh, uh, facility there. It has bulk cargo, it has residential areas. It's been there a long time. King Salmon is a more modern community that was built in the late 40s, in the 50s, is really a recreational fishing RV camp. And they excavated all of these canals so that everybody had a boat launch. And it's converted into a residential community with some commercial interests in there. And there's a lot of people who really love living there, right next to the bay. They don't have much capacity to absorb sea level rise in that location. So does the whole community move? It's not an incorporated community, it's unincorporated. Or as the water comes up, do individual landowners eventually abandon these lands? There's a state legislation that's being considered right now, where the state would buy out property like in King Salmon and Fields Landing, and then lease it back to the current property owner, and they could live there for as long as it's safe to do so, knowing that these areas are susceptible to sea level rise, and ultimately, the utilities won't be able to be provided, or street access won't be able to provide. But rather than these people losing all of their investment, the state may be able to step in, buy out these properties, let these have a lifetime lease, let the people that live there now live their time out, and then essentially abandon and pull these communities and allow the bay to reclaim them. So as I said, that's state legislation that's being considered. It hasn't happened yet. And so one of the other big issues is what's going to happen to the entrance of the bay with 1 and 2 meters of sea level rise. The jetties start going underwater with 1 meter of sea level rise, 2 meters, definitely majority of the jetties are underwater. I imagine they will continue to function, but how are they going to do the dredging? How will that change sedimentation patterns in the navigation channels and in the entrance channels? All of that is really unknown. And looking at where the water will be 100 years from now, you see that Mad River flows into Humboldt Bay. Mad River brings a lot of sediment in the winter. Maybe all of this Mad River slough and Arcata Bay will become a big, huge salt marsh plain with all that introduced sediment. But the sediment could have a significant impact on the entrance to the bay. And you notice in 2120, the bay the opening is greatly expanded. It's no longer confined between the two jetties. So unless they're going to build a new jetty or change the configuration, all of that has to be modeled and figured out. So, and we're just about done. Who's going to do anything about this? And so what often is referred to as stakeholders, people that have a stake in sea level rise. Who are these people that need to come together to start figuring out what can be done and when can it be done and who's going to pay for it? And the broad categories of regional stakeholders are starting with the Wiyot tribe. This is their ancestral land and waters, but certainly the property owners, both private and public, that own the shoreline. That's our first line of defense. And the people that own the property that's going to be inundated between now and 2120, they need to be at the table. Then we have our land use authorities, the county, the city of Eureka and Arcata, and then regulatory agencies like the Harbor District, and more importantly, the Coastal Commission, the Army Corps of Engineers. And then, people like PG&E, our utility service providers, the Humboldt Community Services District, PG&E, and then people responsible for our transportation, Caltrans for Highway 101, the county, for Old Arcata and Myrtle Avenue. And then lastly, there's the general public and public interest groups. They all are really, concerned about sea level rise and who's going to address it. And, they want to be involved with that decision making. And so the county right now is looking into the feasibility of doing regional sea level rise adaptation planning on Humboldt Bay. And so hopefully they will complete their study by the end of the year or beginning of next year. I'm helping them with that study. So hopefully we can get it done in that time. And hopefully we move into doing regional sea level rise planning. Right now, there's 10 projects going on dealing with sea level rise on Humboldt Bay. Well, actually, I take that back, 9. The first project is just completed by the Humboldt County, and that was the Eureka Slough Transportation Study. But the U.S. Fish and Wildlife is doing a Humboldt Coastal Resiliency Project. They're studying the coastal dunes of the North and South Spit to see how they respond to sea level rise. U.S. Geologic Service is creating a new sea level rise model program for Humboldt Bay that will take into account groundwater flooding, wind waves, and other things like that. There's a natural shoreline infrastructure research project that's going on that's also with the U.S. Geologic Service. The county is looking at the feasibility of a natural shoreline for the new Bay Trail between Brainerd and Braycut to see if that would work instead of rocking. All of that, as rocking is very expensive. There's the Wiyot tribe has just recently received 3 grants, and they're looking to build a climate change adaptation program for their ancestral lands and waters. And as I mentioned, Humboldt County is doing a sea level rise feasibility study. There's the Highway 101 corridor sea level rise adaptation planning that Caltrans is doing. And some professors at HSU received funding to study possible futures for the nuclear fuel storage site on Bonner Point. And the city of Eureka is doing a sea level rise vulnerability and capital improvement program adaptation plan. And lastly, the city of Arcata is looking into building a living shoreline project around its wastewater treatment plant. And so if you're interested in the historical development of the Eureka Slough area, and in fact, the whole east side of Humboldt Bay, all the way up to Bayside, Jerry Rohde just published a book that he did for the county as part of their Eureka Slough sea level rise study. And you can find it at the HSU's Digital Commons website, and you can download the full report for free. And so, in fact, if you go to HSU's universities, there's a Sea Level Rise Initiative website. I helped create this organization a year or so ago. And one of our first projects was to collect all of the sea level rise documents that have been produced on Humboldt Bay and all the GIS databases, and to work with the university's library at the Digital Commons and make all of those documents and GIS databases available at HSU's Digital Commons. And you can download any of those documents for free. And that's all I have. That's basically sea level rise in a nutshell for Humboldt Bay with a focus on the Eureka Slough area. So hopefully that made sense.
That was a great presentation. Thank you. There was a lot of information to absorb.
There is a lot.
We have a couple more questions.
Good.
How will people access homes in freshwater, and will this shoreline be tidal?
Well, First off, in order to get to freshwater, they're going to have to raise Old Arcata Road and Myrtle Avenue in several locations, so you'll be able to continue to drive in on that. And for that matter, they're going to have to raise Highway 101. Ultimately, they'll need to put Highway 101 between Eureka and Arcata on a causeway so the bay can go underneath it. But also, from about Indianola, from the traffic circle that they have from about there, going down towards Three Corners Market. There's low areas over there by Cochrane Creek that will flood, and then over again by Redmond Creek when you get near Three Corners. But then Freshwater Creek, is going to increase in elevation and flood. There's actually a causeway right now just south of Three Corners Market as you go down Myrtle Avenue, and you get next to between Three Corners Market and the North Coast Regional Land Trust, the freshwater farms. That part is on a causeway, so the high tides can spread underneath the highway and go up Freshwater Valley that way. And so going up Freshwater Creek and going up through that causeway would be the way that sea level rise would likely, come into the valley and possibly affect the valley. So Myrtle Avenue, as it gets over by Ryan Slough, it gets really low in elevation, over by Devoy Road. Those houses are right down there at the water's edge. So there's a number of spots that the county is going to have to raise the roads so that you can continue to get in there.
The other question is, what happens to areas like Garberville with will the rivers be rising at the same time with the
Well, with climate change, one of the things that I used to be on the board of the Humboldt Bay Municipal Water District, and so we studied the Mad River and how climate change would change it. And what we found is that with climate change, we're not necessarily going to have less rainfall than what we have now. We'll have about the same amount of rainfall, maybe a little bit more, but it's going to come in a shorter period of time. When I first moved up to Humboldt back in 1975, it would start raining in early November or late October and keep raining all the way to April. And now often we don't start getting our rainfall till almost December, and it's usually done by the end of March. So we're getting the same amount of rainfall in a shorter period of time. Well, that's going to become even more extreme. So it means that the storms that we have could be bigger than the storms we have now. So they could raise our river elevations, like the Eel River in Garberville or Shelter or by Scotia. They could be flooded more than what they have in the past. But then come summertime, the rivers could actually go dry. They could go subsurface. So it's the rainfall patterns are definitely going to change, as are the fog patterns, and the low flow season is going to really extend. There's some projections that with the climate change as it continues to progress, by the end of the century, we could have as much as 6 months of summertime, and fall and spring and winter will shrink accordingly. It's already going that way, and they are just modeling, what would happen by the end of the century. And that's pretty amazing because California dries out quite a bit as it is now. We don't necessarily need more summer.
right, right. The next question is, for areas such as King Salmon and Fields Landing, how can the community make sure that the leftover infrastructure doesn't pollute the ocean? Could those locations be, covered to low water, and transferred to a mariculture, aquaculture farming to stimulate our local economy?
I think that what will, in looking at contaminated sites, we mapped where all the contaminated sites, and we figured out how many would be inundated by half a meter of sea level rise going around Humboldt Bay. And in King Salmon and Fields Landing, both of those communities have 5 contaminated sites that are vulnerable to being tidally inundated by 1 meter of sea level rise or by 2060. Probably as those communities are not habitable anymore, and people leave, the county, the state, probably more of the state, is going to have to come in and pull out all of those things, because there could be a tremendous amount of pollution going on from if we just abandon structures and walk away from them. The utilities like the Humboldt Community Services District, they would probably cut off their wastewater collection lines so there's no more sewage coming in or out. I don't kn- I would imagine they would be required to go in and actually pull all the pipes in the same way with PG&E with the gas lines and municipal water lines, and ultimately they would probably would regrade all of that area so it could be reclaimed by the bay without contaminating the bay, I think is the likely direction of it. Some people have talked about doing aquaculture on the dike lands, as we get emerging groundwater. uh, Instead of fighting sea level rise, why not utilize it and start raising kelp or other seaweed or something like that? I don't know. There could be opportunities. It's a unique landscape, but I think those urban communities like Fields Landing and King Salmon, there was a big concern about contamination and contaminating the water quality of Humboldt Bay. So I would imagine they would be demolished, and remove all of that stuff rather than abandon it and let the water just flood all that area.
Okay. Are there any more questions? Anybody? You can turn your video on, raise your hand, type into the chat. Right? I don't see any more questions, so I just want to thank you for your time today. Oh, yes, this is being recorded, and I will, when I get it uploaded, I will send a link out to everybody who signed up today. How about that? And people are saying thank you. That's the next comment. So
All righty, good. Well, I hope you enjoyed it.
yes, thank you very much. You have a wonderful day.
Okay, thank you.
Okay, bye.